Hello friends, in continuation with the previous video, this is again an engineering services examination 2014 question paper, and this is related to basic properties of the soil. So you can just see over here, a soil deposit has a void ratio of 0.9. Its void ratio is reduced to 0.6 by compaction. Determine the percent reduction of volume by this compaction. So if you see this problem, what is given here, you can list it. The initial void ratio, EI, is given as 0.9 and the final void ratio becomes 0.6. So E final or EF equal to 0.6 by compaction. So if you draw the three-phase diagram here, the solid part and the soil deposit is having void ratio, initial void ratio, which is the volume of void divided by volume of soil solids. So this is the volume of void, this is the void, and this is the soil solid. So you can show it like this. So this is equal to 0.9. So EI is given to you as 0.9. Therefore, volume of void becomes 0.9 times Vs. So here volume of void is going to be 0.9 times Vs. Therefore, the total volume, you can find it out. The total volume is V, therefore, total volume V equal to volume of void plus volume of solid. That becomes the total volume. So volume of void is already given to you as 0.9 times volume of soil solids plus Vs. So the total volume becomes 1.9 times Vs. Now, let us go to the final void ratio, EF. So, EF is 0.6 and this is equal to the volume of void upon volume of solid. So, in the three-phase diagram, we can show it the solid part and this is the void. So, volume of void is shown and the volume of solid part is also shown. So, this implies that volume of void equal to 0.6 times volume of solids. So, this becomes 0.6 times volume of solid. Therefore, total final volume, this is the initial volume, Vi. The total volume becomes Vs plus Vv. So the final volume becomes Vs plus 0.6 times Vs. That means it is 1.6 times volume of soil solids. Now, having got the initial volume and the final volume. So Vf and Vi are known to us. Therefore, you can find out the percent reduction of volume by compaction. Therefore, percent reduction in volume will be initial volume. After compaction, the final volume is going to reduce, divided by Vi into 100. So if you substitute the values over here, you can get the answer. So Vi is already known to us. Vi is 1.9. So it is 1.9 times Vs minus Vf is 1.6 times the volume of soil solids divided by Vi is 1.9 times Vs. So this into 100. So this becomes Vs gets cancelled. 1.9 minus 1.6, that is 0.3 divided by 1.9 into 100. This is the percent reduction in volume. So 3 by 19. So 300 divided by 19, we can calculate it. So if we calculate it, %15.78%. 789%. This is the answer. So answer, the percent reduction in volume is 15 point. The answer, we have got it. Let's see the next problem now. The next problem is of 2013, and the problem is like this. The mass of saturated soil sample, the mass of saturated soil sample is 150 grams, is 150 gram, and its mass when oven dried (90 grams). Find the water content. The water content. Suppose that the sample is used for triaxial test. triaxial test has a dia of 38 mm and height of 76 mm, then find the void ratio. So this is of 2030. So let's see the solution of this problem. The solution of this problem, the mass of saturated soil sample. So the soil sample is fully saturated. So if you draw the three-phase diagram, the solid part, soil solid, and this is fully saturated. So the void is completely filled with water. So this becomes the volume of void equal to volume of water. And this is the volume of soil solids. So in three-phase diagram, the volume and its mass is the given over here. This is the mass of water, and this is the mass of soil solids, and the total mass will be the sum of mass of water plus mass of soil solids. So here it is given that the sample is fully saturated and the total mass equal to 150 gram. Therefore, we can say the mass of soil solids plus the mass of water equal to 150 gram. Now, when it is oven dried, then the mass becomes 90 grams. So when it is oven dried, your three-phase diagram, there will be soil solids and here it will be air, oven dried. So this side, it is the volume of air equal to volume of void, and this is the volume of soil solids when air dried. This is the mass of soil solids, and the mass of air will be 0. So the weight in terms of grams, it's going to be 0. So this is the air part. So these are the three-phase diagram, and you can see the here volume of water is known to you, and the mass of water is also known to you. So mass of water when oven dried, this is 1. When fully saturated, When dried completely, then mass of solid plus mass of air is given to you as 90 grams. So this being 0, the mass of solid, therefore the mass of water is 150 minus 90, that is 60 grams. That is the mass of water. And the mass of water, the unit weight of water is going to be 1 gram per cc. Therefore, the volume of water is also going to be known now. The volume of water, therefore, will be 60 multiplied by 1, that is 60 cc. So, volume of water is known to us as 60 cc, right? And the total volume, because the sample is used for triaxial and the diameter is 3.8 centimeter and height is 7.6 centimeter. Therefore, the total volume of the sample can be calculated as V equal to pi d square by 4 multiplied by the height. So it becomes equal to pi, diameter is 3.8 centimeter whole square, into height is 7.6 centimeter, and divided by 4. So cross sectional area of the sample multiplied by height gives you the volume in cc, so much of cc. Therefore, if you calculate, you get the total volume. So total volume, let us calculate. Please let us have our calculator and calculate it. So pi there is 86 point. So volume, total volume becomes 86.192 cc. So total volume is known to us. So total volume is this. This is the total volume, V. So total volume minus volume of water will give you the volume of soil solids. So you can get everything. Volume of water is already known to you, 60 cc. Therefore, volume of soil solids will be total volume minus volume of water. So this is simply 26.192. Now what is to be found out is find the void ratio. So you have to find out the void ratio E, and E equal to volume of void upon volume of soil solids. So what is the volume of void? It is the volume of water, and it is equal to 60 cc. So 60 cc divided by volume of soil solids, we have found out so much of cc. So 26.192 cc. Therefore, the void ratio becomes 60 divided by 26.192 equal to 2.29. 2.29. This is the void ratio. So this is the answer. This is the answer. So with respect to three-phase diagram, this is your three-phase diagram. You are in a position to find out the volume of soil solids. Volume of water was already given to you from the given information, and therefore you are in a position to calculate the void ratio. So this is the problem in 2013. I hope this point has been made clear to all of you. I will go to the next problem of 2012 now. There is also based on the basic relationship and soil properties. So at undergraduate level, all of you have learned about basic properties of soil, basic relationship, three-phase diagram, etc. So a soil sample has a porosity of 40%. The specific gravity of solids is 2.7. Calculate void ratio, dry density or dry unit weight, one and the same, and the unit weight of soil when degree of saturation equal to 50%, and the fourth one is unit weight of soil when fully saturated. Fully saturated. So this is the problem that that has been asked in 2012. This problem, UPSC problem of 2012, and the porosity. So here we can see the solution. The porosity N equal to volume of void upon total volume. So this is given to you as 0.4. So if porosity is known to you and the specific gravity of soil solids is 2.7, you can calculate the void ratio E equal to volume of void upon volume of soil solids, right? So N, if you look to the three-phase diagram, the volume of solids, let's say this is unity, and this is the volume of void, right? And so if volume of soil solid is unity, then this implies that E equal to VV. This becomes void ratio. Therefore, this total volume becomes 1 plus E, the total volume. So N is given to you, therefore N, which is equal to volume of void, is going to be E, and total volume is going to be 1 plus E. This is the relationship which you know it between porosity and void ratio, and therefore 0.4 40% into 1 plus E equal to E, or 0.4 equal to 1 minus 0.4 times E. Therefore, E equal to 0.4 divided by 0.6. So it becomes 2 by 3. So void ratio becomes 0.667. So first part, void ratio, we are able to calculate. Now the second part, this is the first part. The second part is going to be dry unit weight, that is gamma D. Gamma D equal to G gamma W upon 1 plus E. So you can easily calculate this. 2.7 is the specific gravity, 9.81 is kilonewton per cubic meter, divided by E you have just now found out. So 1 plus E becomes, and if you calculate, this will be gamma D will be 2.7 into 9.81 divided by 1.667, 15.88. So gamma D equal to 15.889 kilonewton per cubic meter. So dry unit weight is known to you, right? Now let's go to the third part. Unit weight of soil when degree of saturation. So gamma T equal to G plus E into degree of saturation SR, gamma W divided by 1 plus. So the SR is already given to you here, that SR equal to 0.5. So 2.7 plus void ratio we have calculated as 0.667 into 0.5 multiplied by 9.81 divided by 1.667. So let us calculate this. 17.667 So 85 kilonewton per cubic meter. This is the answer of part 3. So part 3, unit weight of soil when SR equal to 50%. And the fourth one is unit weight of soil when fully saturated. When fully saturated, degree of saturation SR will be 1. So therefore, gamma saturated will be G plus E. SR becomes 1 gamma W upon 1 plus E. So we will substitute and calculate 2.7 plus 0.667 into 9.81 divided by 1.667. So if you calculate this, let us calculate 2.7 plus we get the saturated unit weight comes out to be 19.81 kilonewton per cubic meter. So this becomes the answer. So this is also known to you, 19.814 to be precise, 19.814 kilonewton per cubic meter. So friends, we are in a position to calculate we have been able to solve these questions, which is based on the basic soil properties and interrelationship. You have learnt it. As we proceed further, our quality of questions will be also tough. It will be the more conceptually you will have to attempt it. So if you are very clear about the basic or the fundamentals, then you can make use of the relationship and solve any problem. Thank you very much. So this is how you will have to do it.